Hello students, in this video we'll be discussing the remaining questions of application of derivatives and maxima minima. So let us begin with the first question for this video. The first question that we have students is from maxima minima concept. Let us take this question number 98. The length of the perimeter of a slice of a pizza is in the form of a sector of a circle and that length is 20 centimeter. So students, it is given that, I'll highlight this quickly, this sector is one slice of the pizza. This length, like the full perimeter, which includes the two radius and this length of arc, this is 20 centimeter. So let us begin, students. We'll form the equation over here. Now, when we say length or the perimeter of this pizza slice, it consists of the two radius and the length of arc. Now, the two radius, students, will be 2r plus the length of arc is r theta, where theta is in radians. We'll take r theta because in the question also they have mentioned theta is in radians. And this is 20, students. You read the first subpart, express the radius in terms of theta. So in the first subpart, students will express the radius in terms of theta. I'll take radius common. So this is theta plus 2. That is 20. And we get r is equal to 20 upon theta plus 12, where theta is in radian. Second, let A be the area of the slice, then express area in terms of r. Now the formula for area, students, is half r square theta. We want to express this in terms of r, which means we now want theta in terms of r. From this same equation, r theta will be 20 minus 2r. So theta will be 20 minus 2r upon r, which means area will be half r square into theta, which is 20 minus 2r upon r. Students, the sum is actually not difficult. It's super easy, provided you remember the formulas of length of arc and area of sector. So now we'll solve this. This is a normal maxima minima question. 1r will get cancelled, which leaves us with 20r minus 2r square upon 2. Once you get this, students, the second part is also done. About the third part, for maximum value of A, we are now talking about maxima minima, students. Over here, they are saying maximum value of A. So we have to take area as the function, and then you have to go ahead with the double derivative test. So we'll take derivative, double derivative, and all of that. So let us do that. When we take the derivative of this function, the derivative, I'll call this function f of r as 20r minus 2r square upon 2. You can actually divide it by 2 so that we are not having any denominator. It's 10r minus r square. You take the derivative, students, f dash r will be 10 minus 2r. You equate it with 0 and you get that r is 5. You take the double derivative, students. The double derivative in this case is minus 2, which is lesser than 0, and therefore it is maximum when r is 5. We'll substitute in this equation 10r minus r square, so we get 50 minus 25. So the maximum area is 25 centimeters square. And that completes D as well. We are left with C. I missed the C part. We have to find the value of the angle. So r is 5, students. You substitute that in this equation of theta. So theta is equal to 20 minus 2 into 5 is 10 upon 5. So do you understand, students? This is 10 upon 5, which is 2 radians. Theta will be 2 radians for maximum area. Would that be complete the sum? Let's proceed to next question, which is question 103. The next question, students, is question 103. We have to find the acute angle between the curves y is equal to mod x square minus 1 and y equal to mod x square minus 3 at their point of intersection. Remember, students, whenever they say angle between two curves, it means angle between their tangents at that point. Tangents are straight lines. So for that, we'll be using this straight line formula. Angle between two lines is given by tan theta is equal to mod of m1 minus m2 upon 1 plus m1 m2. We'll be using this concept. Further, we need to figure out the point of intersection, students. Point of intersection will be that point where y coordinate will be same, which means mod of x square minus 1 has to be equal to mod of x square minus 3. Now you solve this. So over here, students, I'll remove the modulus. Now when I remove the modulus, it is either positive of x square minus 3 or it is negative of x square minus 3. I hope you know this concept. When we remove modulus, it's either plus or minus on any one side, not on both sides. See, this can't be solved. So you skip this, but we can solve this. So 2x square is equal to 4. You get x square is equal to 2. X is plus minus root 2. So students, the x coordinate is plus minus root 2. So if I take x as root 2, then when you substitute, you will get this is as 1. And when you take x as minus root 2, you'll get the y coordinate is still 1. So students, we have the 2 points in this sum. Because they have mentioned x is positive, we will have to consider only this point, root 2 comma 1. So now, students, once we have the value of x, which is root 2, now we have to find the slope of both the lines, the curves. We have to find slope of both the tangents. So students, for that, y is equal to mod x square minus 1. Do you understand, students? When x is root 2, when you substitute root 2 square is going to be 2. 2 minus 1 is positive, which means in the neighborhood of root 2, this function is going to be positive. So we'll take it as y is equal to x square minus 1. So the derivative is equal to 2x, which means the slope of the first tangent is 2, root 2, because x is root 2. Next, for the second curve, y is equal to x square minus 3. When you take the same point root 2 students, root 2 square is 2, 2 minus 3 is minus 1, and therefore it is negative in the neighborhood of root 2. X square minus 3 will be negative, and therefore when you remove the mod, it will be negative x square minus 3. So this time the derivative is minus 2x, which means the slope is minus 2 root 2. And now students will use this tan theta formula. So tan theta is equal to mod of m1 minus m2 upon 1 plus m1 into m2. To solve this for the students, in the numerator, we have 2 root 2 plus 2 root 2, which is 4 root 2. Denominator will be 1 minus 2 root 2, the whole square is 8. So it is 1 minus 8, which is 7. So theta, students, is going to be tan inverse of 4 root 2 by 7. You can use your calculator, students, and you can find this angle using the calculator. Next, students, will take question 104. Y is equal to ln of x plus 1 minus ln x is a curve. The tangent to the curve at point P meets x-axis at A and y-axis at B. The normal to the curve at P meets x-axis at C and y-axis at D. All right. So first of all, students, let us do one thing. Let us do the first subpart where we have to find the slope of tangent at P and slope of normal at P. For slope, we'll have to take the derivative. So we'll take the derivative of this curve. Derivative is equal to ln of x plus 1 is 1 upon x plus 1 minus ln x is 1 upon x. You take LCM, students, this will be x minus of x plus 1 upon x into x plus 1. So from here, students, will get minus 1 upon x into x plus 1. In the first part, students, slope of tangent. Now they're saying point P is 1, comma ln 2. So x is 1. So you substitute x as 1 in this equation. The minus 1 upon x into x plus 1 will get minus half. That is slope of tangent. Normal, students, I hope you know this basic rule. It is perpendicular to tangent, so reciprocal and sign change. So this is 2. So that completes the first subpart. Second, we have to find the equation of tangent and equation of normal. This is also easy. I hope you remember the formula for straight line. Y minus y1 is m into x minus x1. The only issue is this time y coordinate is ln 2, but don't worry, you just keep copying it as it is. So for tangent, this is going to be y minus y1 is ln of 2 is equal to m. For tangent, it is minus half. X minus x1 is 1. When you cross multiply, we have 2y minus 2 ln 2 is equal to minus x plus 1. You take everything on same side, x plus 2y minus. The maximum you can do is you can take this 2 in the power, you can write it as ln of 2 square, which is 4, and that minus 1 is equal to 0. This is the equation of tangent. Once you complete the tangent part, you have to move ahead with the normal part. For normal, students will use the slope as 2. So we'll get y minus ln 2 is equal to 2 into x minus 1. You open the brackets, y minus ln 2 is equal to 2x minus 2. You take everything on the same side. The equation is 2x minus y plus ln 2 minus 2 equal to 0. That is the equation of tangent. Now we have to find the coordinates of A and C, students. Focus on A, students, first. A is point on x-axis. And they're saying the tangent meets x-axis at A. So we'll use the tangent equation. When we say x-axis, students, we'll put y as 0. When we put y as 0 in this, x is equal to ln 4 plus 1. So do you understand, students? Coordinates of A will be ln 4 plus 1, comma 0. That is your answer. The normal means the x-axis at C. So now students will take the normal equation. We'll put y is equal to 0 over there. So we get 2x plus ln 2 minus 2 is equal to 0. So from here, x is equal to 2 minus ln 2 upon 2. So final coordinates of C is equal to this coordinate, comma 0. Just copy this. It's 2 minus ln 2 upon 2, comma 0. With that, students, we complete this part as well. We'll proceed to the next one, which is 132. Oh, beautiful question, students. I love trigonometry, so this question is going to be super fun. A lot of subparts, so let us begin. The function f of x is given to us cos x plus root 3 sin x. The diagram is shown below. The y-intercept is at 0, 1. We can see that. It intersects x-axis at C and D. We can see that also. The minimum point is at A, maximum is at B. Great. We have to first find f dash x, and we have to write it in this form, lambda into cos of x plus mu. Now, students, this is that question where we will actually be using the concept of 11th grade trigonometry to convert this in the form of a single sine or cos. So I'll tell you what do I mean by that. I hope you have seen the previous video where we have discussed one such example. If not, you should see that and then come back to this, because here I'll run through it. I expect you to already know this. So here in the first subpart, students, the function f of x is equal to cos x plus root 3 sin x. Root 3 is related to sine and cos, as sine 60 is root 3 by 2, cos 30 is root 3 by 2. So students, I'll multiply and divide by 2. We'll multiply and divide by 2. Now, students, when we multiply and divide by 2, we'll get 2 into this is sine of 30. This is cos x plus cos 30 and sin x. Now, students, this will become 2 into sine of, I hope you remember the compound angle formula. This is 2 into sine of 30 plus x. So this is my final function. F of x is equal to 2 into sine of pi by 6 plus x. You take the derivative of this, taking derivative is super easy. Sine will become cos, and derivative of pi by 6 plus x is simply 1. So the final derivative is 2 cos pi by 6 plus x. And now students, you have to compare this equation with this equation. Do you figure out that lambda is equal to 2 and mu is equal to pi by 6? So we have to now find the value of q. Now students, here q is the y coordinate of a, which means you have to find the minimum value of a. If you're thinking about maxima minima procedure, you can go ahead with that, but it will take a lot of time. What we can do is we can use the basic concept of sine and cos. Now, do you know that for sine of any angle, the minimum value is -1? And therefore, students, the minimum of f of x is -2 in this sum, because it's 2 into -1. And therefore, students, q in this question is going to be -2. Further, students, we'll take the next subpart. We have quite a few subparts in this question. The next subpart, students, is where to find the coordinates of point B. Do you understand, students? Point B is at this point. It's the maximum value of this function. Now, the maximum value of this function, students, that is sine of pi by 6 plus x, maximum of sine of pi by 6 plus x is going to be 1. And we know that sine of 90 is 1. That is the maximum value. So do you understand this will occur at x equal to pi by 6 is 30 degrees. So x has to be pi by 3, which is 60 degree. Basically, I'm saying that at x equal to this point, x equal to 60 degree pi by 3, the corresponding value is 2. Why is it 2? Simply because the maximum of sine of pi by 6 plus x is 1. So the maximum of overall function, when you multiply it with 2, that will be 2. So students, I hope you are understanding this. The coordinates of B, the x coordinate is pi by 3. The y coordinate is 2. Further, students, we have to find the interval in which f of x is decreasing. Now, students, when we say that f of x is decreasing, do you understand? Derivative has to be less than 0. And we already have the derivatives. So students, you take the derivative and you check where is it decreasing. So over here, students, let me, So now, students, the next subpart, we have to find the interval in which f of x is decreasing. Now, do you understand, students, that the function is decreasing from the graph? We can go ahead with the normal procedure f dash x less than 0, but graph is given, students. Use the graph, it will become really easy. Do you understand, students, that this is the portion of the graph from B to A where it's decreasing? So if we can figure out the coordinates of A, we are done. Now, for A, students, we know we have already found Q. Q is -2, which means the y coordinate is definitely -2. We're talking about minima in this case, students. So you have to understand that this function 2 sine of pi by 6 plus x, I'll write it over here. So we have 2 sine of pi by 6 plus x. The minimum value of this is -1. So the overall minimum value is -2. When now sine of which angle is -1, you have to figure that out. I hope you already know the students. Sine of 3 pi by 2, that is 270, is -1. So students, this will be minimum when x plus pi by 6 is 3 pi by 2. You find x from here, students. X is equal to 3 pi by 2 minus pi by 6. Take LCM in this. So you multiply, divide this with 3. You will get 8 pi by 6, which is 4 pi by 3. So this is 4 pi by 3, which means the x coordinate for this A is 4 pi by 3. So it is decreasing in the interval pi by 3 to 4 pi by 3. So here we get x is 4 pi by 3. Now, students, we have to find the slope of tangent to the curve at this point D. Do you understand, students? D is on x-axis. We have to figure out the coordinates of D and then slope of tangent. Now, students, to find D, do you understand that here y coordinate will be 0 because it is on x-axis, which means 2 sine of pi by 6 plus x is equal to 0. So here, students, sine of pi by 6 plus x is 0, which means sine of, we know that 0 degree is 0 and 360 is 0 and pi is 0. So here, students, x plus pi by 6 will either be pi or it will be 2 pi, which means x will either be pi minus pi by 6, which is 5 pi by 6, or 2 pi minus pi by 6, which is 11 pi by 6. You have to understand, students, that C will have x coordinate 5 pi by 6 because that is the lesser value, and D will have x coordinate 11 pi by 6. That is the bigger value. So now, students, you check the slope. Now, for checking the slope of tangent, we have to take the derivative. Derivative is already ready, students. So I'll directly use that derivative. Now, here the derivative is this function, students. You have to substitute 11 pi by 6 in this. I'll do the working very quickly. So here, students, the derivative will be 2 cos of pi by 6 plus 11 pi by 6. Do you understand, students? This will be 12 pi by 6, which is 2 pi. So you'll get 2, which means the slope of tangent at this point is 2. You'll get 12 pi by 6, which is 2 pi, and cos of 2 pi is 1, student. So therefore, 2 into 1 is 2. So slope of tangent is 2. That leaves us with the last part, slope of normal to the curve at C. Now students, for slope of normal at C, we'll first find slope of tangent. We already have the derivative. You substitute for the F part, you substitute x as this 5 pi by 6. So this is going to be cos of pi by 6 plus x, which is 5 pi by 6. When you solve this, students, it's going to be cos pi. Cos pi is -1. I hope you know that. If you don't, you can use your calculator. Slope is -2. When we say slope is -2, slope of normal will be reciprocal and sign change. So that is half. I hope you have understood this, students. It had a lot of subparts. I hope all of them are clear. You can write this on a paper systematically. You'll get this sum very easily. That leaves us with the last question, students, from application of derivatives, question 134. In question 134, we have this situation. Sonia watches a painting which has its bottom edge 2 meters above the eye level and its top edge is 3 meters above the eye level. So this is the painting 1 meter high. Now students, alpha and theta are shown. We have to find tan alpha and tan of alpha plus theta from the figure. So from the figure, students, tan of alpha is going to be 2 by x. That is super easy. Alpha plus theta means this full angle, students. Tan of that will be 3 by x. So this is 3 by x. We have to now find theta in terms of x. We have to now find theta in terms of x, which means, students, we have to get rid of alpha. So here you have to understand that alpha plus theta minus alpha is theta. So what I'll do is I'll use tan theta is equal to tan of alpha plus theta minus alpha, this basic relation. So students, tan theta will be equal to tan of alpha plus theta. We are using the compound angle formula, minus tan alpha upon 1 plus tan alpha plus theta into tan alpha. Now tan theta, students, we want to find that tan of alpha plus theta is 3 by x minus tan of alpha is 2 by x upon 1 plus tan of alpha plus theta is 3 by x into this is 2 by x. You keep solving the, students, we'll get 1 by x upon 1 plus 6 by x square. You take LCM, students, this is 1 by x into x square upon x square plus 6. So finally we are getting tan of theta is equal to x upon x square plus 6. So my final answer, students, the final answer that we will be writing, that is going to be in terms of theta. So we'll remove tan from the left, which means we'll take it as tan inverse. Theta is equal to tan inverse of x by x square plus 6. This, students, is the function. For the third part, students, we have to find the derivative of this. We'll have to use UV rule, chain rule. So this is going to be 1 upon derivative of tan inverse is 1 upon 1 plus x square. So this will be 1 upon 1 plus x square upon x square plus 6, the whole square, into derivative of this with UV rule. So now, students, will quickly run through the UV rule part. So it is going to be v derivative of x is 1 minus x into derivative of x square plus 6 is 2x upon v square. So that is x square plus 6, the whole square. You simplify this with LCM. So over here, it is going to be 1 upon x square plus 6, the whole square, plus x square upon x square plus 6, the whole square, into, you open the brackets here, this is 6 minus x square upon x square plus 6, the whole square. This x square plus 6, the whole square is getting cancelled. So the final d theta by dx is equal to 6 minus x square upon x square plus 6, the whole square, plus x square. This is the final d theta by dx. Once you get the, students, the d part is easy. You have to find the values of x for which d theta by dx is 0. So here this will be 0 when numerator will be 0. So 6 minus x square is 0. So x square is 6, which implies x is plus minus root 6. We'll consider plus root 6 because x can't be negative over here. Now, students, the last part, you have to use the first derivative test and find the distance Sonia should stand from the wall to maximize her viewing angle. So students, when we say the distance from the wall, we are talking about x. We have to find x for maximum theta and using the first derivative test. We have found the value of x, it is root 6. So this, students, is root 6. Now, students, to the left of root 6, take any random number. Do you understand? Root 6 is basically 2 point something. I'll take 2 to the left of root 6. When you substitute 2 in this, students, you have to check whether you are getting a positive answer or a negative answer. When you substitute x as 2 in this, we'll get a positive answer, which means the derivative in this case is increasing. Further, you take any number to the right of root 6, I'll take 3. When you substitute 3, you'll get a negative number, students, which means at this point it is maximum. And therefore, we can say, students, for maximum viewing angle, the value of x is root 6. The distance has to be root 6 meters from the wall. With that, we complete this question. And with that, we complete all the questions from Maxima Minima and application of derivatives. This, in fact, students, were the only tricky questions. I hope students have understood them. In the next session, I'll see you with integration. Thank you.